Hi, and welcome to day 3 of Intro to Trig Part 2. Today we're going to be talking about the Pythagorean identities, but first let's review some of our reciprocal functions. Remember, secant theta is equal to 1 over cosine theta, cosecant theta is equal to 1 over sine theta, and cotangent is equal to 1 over tangent theta. Also, tangent theta is equal to sine theta over cosine theta, therefore cotangent theta is equal to cosine theta over sine theta. Those are going to come in handy. All right, we have the Pythagorean identities. Everybody knows the Pythagorean formula, which is a squared plus b squared equals c squared. And we've talked about our unit circle and our triangle on the inside. And this point over here is 1, 0, and this is 0, 1. And my hypotenuse is 1, my angle is theta, and this length is x, and this length is y. So I'm actually going to use this triangle inside my unit circle and use the Pythagorean theorem at the same time. A is going to be my distance for x. So in place of a, I'm going to put in x squared. Plus b would then be y, plus y squared equals c, which is the hypotenuse, which is 1 squared. We also learned that x was cosine. So cosine theta squared plus y is sine. So it's sine theta squared is equal to 1. And then we're just going to rewrite it. So it's cosine squared theta plus sine squared theta equals 1. This is one of our Pythagorean identities. Okay? And I could prove this to you that it works. If theta were equal to pi over 3, which is 60 degrees, and just to kind of get ready, I know I'm going to need my 30, 60, 90 triangle. This is 1, 2, radical 3. If I use the formula, cosine squared theta plus sine squared theta equals 1. If I put in 60 for theta, cosine squared of 60 plus sine squared of 60 equals 1. The cosine of 60 would be adjacent over hypotenuse, so it's 1/2. So 1/2 squared plus sine of 60, sine is opposite over hypotenuse, so it's radical 3 over 2 squared equals 1. Well, 1/2 squared is 1/4, and radical 3/2 squared is 3/4. So 1 is equal to 1. Okay, so that's why the theorem works, or how it works, I should say. And we have one identity, but from this one identity, we can get the other two Pythagorean identities. So, first I'm going to divide all by cosine squared theta. So if I start out with my identity, cosine squared theta plus sine squared theta equals 1, and I divide everything by cosine squared theta, cosine squared theta divided by cosine squared theta cancels out, and I'm left with 1 plus sine squared theta divided by cosine squared theta is tan squared theta equals 1 over cosine is secant squared theta. So this is identity number 2. And I'm going to divide all by sine squared theta. I divide everything by cosine, I can divide everything by sine. So I have cosine squared theta plus sine squared theta equals 1, divide everything by sine squared theta. Cosine squared theta divided by sine squared theta is cotangent squared theta. Sine squared theta divided by sine squared theta is 1. And then 1 over sine is cosecant squared theta. So I end up with 3 identities. I have actually seen them ask you on a Regents exam to derive one of these 2 formulas given the original. Okay, so examples, how do we use this? What do we do with this formula? If tan B is equal to -3/4 and angle B is in quadrant 4, find the secant of B. So basically you want to look for the formula that has tangent and secant in it, and that is this one here on the left, and that is 1 plus tan squared theta equals secant squared theta. So in place of tan, we're going to put -3/4. So it's 1 plus -3/4 squared equals secant squared theta. So it becomes 1. Anything squared is positive, so it's plus 9/16. When I square 3/4, I get 9/16 equals secant squared theta. 1 turns into 16 over 16, because I need a common denominator to add. So 16 plus 9 is 25. 16th is equal to secant squared theta, but I just need secant, so I need to take the square root of both sides. So I will get plus or minus 5/4 is equal to the secant of theta. We are in quadrant 4. So in quadrant 4, secant theta is positive, therefore the secant of B is equal to 5/4. Okay, for number 2, if cosine A is equal to the square root of 5/3 and A is in quadrant 1, find the sine of A. So the formula has sine and cosine was the original one. So it is cosine squared theta plus sine squared theta equals 1. Now our angle here is A, the other one was B. Doesn't really matter. Radical 5/3 goes in for cosine. So I have radical 5/3 squared plus sine squared theta equals 1. So then I get 5/9 plus sine squared theta equals 1. Well, I need to get sine squared alone, so I'm going to subtract 5/9 from both sides. So that cancels out. I have sine squared theta equals, well, 1 minus 5/9 is 9/9 minus 5/9. And 9/9 minus 5/9. So we have sine squared theta equals 4/9. Then take the square root just to get sine theta, and that becomes plus or minus 2/3. We're in quadrant 1, so everything's positive in 1. So sine A is equal to 2/3. Okay? Right in terms of sine and or cosine. This is kind of what we've been working on before. If I have sine A, that stays as it is. And secant A is 1 over cosine A. So when I multiply them, I get sine A over cosine A. Cosine squared theta plus what is equal to 1? Well, that's one of our identities. Just fill in the blank. So it's sine squared theta. 1 plus tangent squared theta is equal to, that's secant squared theta from our identities on the front, but we want it in terms of sine and or cosine, so it's 1. Plus tangent is sine squared theta over cosine squared theta, which is equal to 1 over cosine squared theta. This is actually A, so I'm going to go back and change these two A's. Sorry about that. And we got one more. Secant minus cosecant over secant. Well, let's make our substitutions. Secant is 1 over cosine theta minus cosecant, which is 1 over sine theta, all over secant, which is 1 over cosine theta. Find your LCD, because this is now a complex fraction, and that is sine theta cosine theta. So you need to multiply every single term by sine theta cosine theta. So in the first fraction, the cosines cancel out, and we're just left with sine theta. Here the sines cancel out, so it's minus cosine theta. Here the cosines cancel out, so we're just left with sine theta. This can then be broken into two fractions. Sine theta over sine theta minus cosine theta over sine theta, which would then be equal to 1 minus cosine theta over sine theta. These are often questions that are multiple choice, so sometimes you could stop here, sometimes you might stop here. It all depends on what the actual directions say, what type of question it is. And that's it for today.